Okay? So here's just a restatement of our assumptions here. Our critical value is 10. Our K is 10. Our probability using Chebyshev's inequality, our maximum probability is 0.01. Okay? Now we're going to assume that our data fits the normal distribution, and we're also going to calculate the PPK. Okay? So one thing that we know is we take our spec limit minus mu over 3 times the standard deviation. We can actually split that up to 1 over 3 times the spec limit minus mu over S, which we know that this is just our K. So we can take 1 over 3 times K. So our PPK can also be represented when talking about Chebyshev's inequality as K over 3. So if we take 10, we say, okay, plug in our K, 10, and we get our PPK equals 3.333 repeating. So now let's actually calculate our out of spec condition. So we know that with a K value of 10 and a PPK of 3.333, we can plug in either 3 times the PPK or just the K, because that would be a Z-score. We can plug that in Excel to get the probability of a value less than that, right? So we plug that in and we take 1 minus that so we can get the probability of an out of spec, which is basically 0. Excel cannot hold on to a number that small. So what that means is that at a PPK of 3.333, you now have a statistical probability of an out of spec condition so low that the 16 digits that Excel carries can't even show you the probability of that happening. Whereas when you use Chebyshev's theorem, you get a probability, a maximum probability of 1%. So that would be why we use capability. Because if K equals 10, according to Chebyshev's inequality, the maximum probability of failing is 0.01. But according to PPK, the maximum probability is negligible, basically 0. And this is because Chebyshev's inequality is for any arbitrary distribution, while PPK is the known one for the known normal distribution. So Chebyshev's inequality just states that it has to be below 0.01. Not that it is, but that it has to be below that.